Finding area of polygons. So in the previous video, I briefly discussed perimeter, and I just kind of refreshed your minds for those that maybe have forgot. But now we're going to go over area. And this is where things are going to get a bit difficult in the sense of formulas and understanding differences between a base and height and a certain side length and whatnot. So we're going to go over finding the area of some basic polygons. So in this video, I'm going to find, there's going to be two parts. There's going to be basic polygons, and then there's going to be complex polygons, and they aren't going to be super complex. It's nothing like with 50 sides and like they're all different or anything. So we're going to go over basic polygons, that being triangles, trapezoids, and parallelograms. So let's go over triangles here. So triangles. So let's say we want to get the area of a triangle. With the area formula, there's actually a formula that's universal for triangles. And the area formula comes in two ways. It depends who teaches you or what sources you see. But there's two formulas and they just mean the same thing. They're just written differently. So there's A is equal. So A is area. A is equal to 1/2 B times H, base times height. Or you might have seen it as in BH over 2. So there's two ways you could have seen it. That's base times height divided by 2. Or 1/2 BH or 1/2 base height. Either way, they're the same thing. Me personally, I'm going to be using 1/2 BH. It just looks better for me. But it doesn't matter what ways, in what way you use the formula. So let's look at this on a triangle visually, because it's going to be you probably don't know what the base or the height is referring to. So we're going to go over a triangle, and I'm just going to show you what that means. And keep in mind, this is universal for all triangles, all. Unless you have like 50 sides, it's not even a triangle. But let's look at this basic triangle here. So what is the base? What's the height? What are we working with? So first of all, the height is this. This is the height of the triangle. There's one important thing. So the height, you're typically going to draw a line from here to here. So you might be familiar, this height is called the altitude of the triangle. And it's typically it typically goes from this top point here all the way down to the hypotenuse of your triangle. And this is called the altitude, and in this case it's called the height of the triangle. So all the height is, and I'm going to do it in a different color actually. I don't know why I did that. I'm going to do it in red so you guys can see better. The height is just from here to here. It's this red line. It's the altitude of the triangle. This red line here is the height. And I'm just going to draw a little H by it. This is the height. Now, what is the base? I'm going to do this in green so you guys can see. The base of the triangle is from this point to this point this segment that I drew here. It's from those 2 points. So this is the base of the triangle. So essentially what this formula says is it's 1/2, let me do it in black here. It's 1/2 multiplied by the base, so base B, and let's go back to black, multiplied by the height. This is the formula. And I can rewrite that for you guys for those that are still a bit confused. It's okay. So base times height divided by 2. These are equal. So these are the same equations, just written differently. They give you the same. They yield the same numeric value in the end. And that's how you find the area of this triangle here. And why is this? There's actually a reason. I'm going to explain it. And it's actually fairly simple. So I'm going to try to recreate that triangle to the best of my ability. But actually, let me start with a rectangle. And this is going to make sense here in a second. So let's say we have a rectangle. And now let's try drawing this triangle, this exact triangle, into this little bit here. So if I start here, and we'll say goes up to about here, and then it goes here. So this is why it's 1/2 and not like 1/3 or like a square root of something or anything. So if you take this triangle, so let's say this red shaded triangle here is the same thing as this. So this red shaded triangle is this, right? Why it's 1/2 is because here's the thing. You could take this triangle, and you can cut it right down here, right? So you notice how this is 1/2 of this, right? So basically what you can do is you can take this triangle that I'm outlining in red. You can take that triangle that I'm about to fill in here. You can take this triangle and map it over this line. You can flip it over that line. It's the exact same area, right? And same with this triangle. This triangle here I'm outlining in red, this is half of this, right? So in essence, the reason why it's half of that is because if you put it into a rectangle, it's always going to be half, right? So this goes here, that goes here. So this and this, these two red shaded triangles that I gave you can make another one of these triangles that we originally drew that I'm going to shade in the green. So these two red shaded triangles, if you cut them out, like if this was a piece of paper and you cut them out, you can make this exact same triangle here. So that's the area equation for triangles, and that's why it's 1/2 times base times height. Now let's go ahead and I'm going to push this aside here. So let's push that down here. Let's push that down here. And let's look at the next type of polygon here. So the next type of polygon is a trapezoid. So trapezoid. So the trapezoid is a bit different in the terms of its little equation here. So let's get a nice looking trapezoid. So you can see two forms of trapezoid. So we typically, when we look at a trapezoid, we think of something like typically like half of a hexagon. Like if you took a hexagon and cut it in half. That's what we typically think. But you can also see trapezoids a bit different. I'm just going to draw with my pen here. So you can see like a line like that, and then you can see a line like that, and it's kind of like, it kind of looks like if you took one of these basic trapezoids here that I just drew here, and you just cut right here. It's kind of what it looks like. So these are both trapezoids, and I want to make this clear. This is a 90-degree angle. It's straight up. It's vertical. So the equation still applies for both of these trapezoids. The area is still going to be the same. So the area equation is a bit more complicated. And that area equation, A is equal to, so area is equal to the height of the trapezoid multiplied by the first base plus the second base here. And then we're going to divide this by 2. And it's kind of the same reason, just because this right here makes a triangle, but here also is half of that. It's very similar. Or you can also rewrite this equation to 1 over 2h times b1 plus b2. The same thing. Let me make that a b so you understand here. These are the same equations. And let's make a trapezoid. I'm going to copy this exact trapezoid here. Let me find, I don't know how to copy this, but we're going to move this down actually. Let's just do that. So what's the height, what are the bases, what's going on here? And in fact, I'm also going to move this guy down here as well. So we have 2 references we can base off of here. So let's look at this basic trapezoid that we typically think of. Well, first of all, this is a base. So let me do that in a different color here. Let's do it in green. So this from here to here, and in fact I'll draw over the trapezoid. This line right here, this right here, this is a base. It could be either base 1, base 2. No matter what, you're still going to yield the same response, the same answer. It's a base though. And then this other one's also a base. And in this example, this will be base 2. And then what about the height? So actually similar, just like the triangle, it's not, the height is this right here. So it's this right here. This is the height. That is the height of the trapezoid that we're looking at. And we're just going to take the height, multiply it by these two bases added together, and then divide the whole thing by 2. So we're going to say 1/2 multiplied by the height, which is then going to be multiplied by base 1 plus base 2. And the same thing applies to this trapezoid. This is going to be the height, so that's the height. This is going to be the any base. It could be base 1 and base 2. And then this will be the other base. And the formula still applies, even though this is vertical and this is a 90-degree angle, the formula still applies. So the formula is still going to look the same here, no matter what type of trapezoid you're looking at. As long as it's actually a trapezoid, then you're going to be set here. You're going to be able to find the area. Now, lastly, since this video is quite long, we're going to look at parallelograms. Parallelograms it has a very basic, it's probably the most basic and memorable formula out of all of this. Now, we know that rectangles is just height times width, but parallelograms here, so let me make this in black. Parallelograms. So parallelograms. So we know that parallelograms are a bit different, but the formula is it's actually very similar to that of the rectangles. So we know a parallelogram looks like this. All sides are parallel, not to each other though. There's two sets of parallel lines in the parallelogram, hence the name parallelogram. Do need to fix this a little bit though. So this is our parallelogram. So we know that the area formula is equal to base times height. In fact, I could probably make it a bit better here. Area is equal to base times height. A is equal to BH. So what is the height? Just like the rhombus and the triangle, the height is this little piece here. So it's this. And then the base, well, since these two lines are parallel, so since this line right here is parallel to this, and it's a parallelogram, assuming it's equal, and these have to be equal for it to be a parallelogram. If this was shorter, it wouldn't be parallel with this other line. So these two sides have to be the same. So this is going to be A, this is going to be A. In fact, I'm just going to say B since that is just the base. But these two green segments that I just highlighted, those are the bases. That's the base. We only need the length of one. You don't need to add them or multiply them. So why is it this formula and not just like length times width? Well, it's actually because just like the triangle I mentioned, if you took this piece right here and this little black highlighted triangle that I just made, and you cut that off like this is a piece of paper, and you were to insert it right here, you'd get a full rectangle. You get a perfect rectangle. So it's very similar. So that is the introduction to finding area of polygons. I highly recommend you take notes and remember these formulas. You don't have to remember them like the back of your hand, but I recommend that you take notes and write down these formulas for these area of these polygons.